use Gaussian elimination to solve the system. First, we're going to start by writing the augmented matrix for the system, which is the matrix of coefficients. 3, negative 2, 1, negative 3. 2, 3, negative 3, 5. And 5, 1, negative 2, 2. All right, so we want to put this system in row echelon form. It's going to be easier if I can work with a 1 up here in this corner, and I see a real easy way to get that, so I'm going to do it. If I simply multiply equation or row 2 here by negative 1 and add it to row 1, I'm going to get a 1 up here. So that's what I'm going to do. I'm going to take negative 1 times row 2, add it to row 1, and put it into row 1. So negative 1 times this is negative 2, added to 3 is 1. Negative 3 added to negative 2 is negative 5. Negative 1 times this will be positive 3, added to 1 is 4. And negative 1 times 5, negative 5, added to 3 is negative 8. Then I'm just going to rewrite the other 2 rows. All right, so the reason for doing that is because now I can easily get the zeros below that 1, which is what I want to do for my row echelon form. And so I'm going to now leave the first row alone. And I'm going to multiply the first row by negative 2, add it to the second row, and replace the second row with this. So negative 2 times 1 is negative 2, added to 2 is 0. Negative 2 times negative 5 is 10, added to 3 is 13. Negative 2 times 4 is negative 8, added to negative 3 is negative 11. And negative 2 times negative 8 is 16, added to 5 is 21. And for the last row, I also want to get a 0 here, so I'm going to do that by taking negative 5 times row 1, add it to row 3, and replace row 3. So negative 5 times 1 plus 5 is 0. Negative 5 times negative 5 is 25, plus 1 is 26. Negative 5 times 4 is negative 20, minus 2 is negative 22. And negative 5 times negative 8 is 40, plus 2 is 42. All right, so I also need to get a 0 here where the 26 is. And I see a real easy way to do that. If I just multiply 13 by negative 2 and add it to 26, that will give me a 0. So now I'm going to leave the first row alone. I'm going to leave the second row alone. But I'm going to take negative 2 times row 2, add it to row 3, and replace row 3. So negative 2 times 0 added to 0 is still 0. Negative 2 times 13 is negative 26, plus 26 is 0. Negative 2 times negative 11 is 22. 22 minus 22 is 0. And negative 2 times 21 is negative 42. Negative 42 minus 42, or plus 42, is also 0. All right, so now we see we have here a row of all zeros. So what that means is we have a dependent system. So we can let z equal any value. Let's call it t. Now our second row here represents the equation 13y minus 11z is equal to 21. So 13y minus 11t, being our parameter, is equal to 21. So in terms of our parameter t, adding 11t to both sides and dividing by 13, y is 11t plus 21 over 13. And then to get the value of x, we look at the top row, which gives us the equation 1x minus 5y plus 4z is equal to negative 8. So now, plugging in what we know, x minus 5 times, for y, I'm going to put in 11t plus 21 over 13. For z, I'm going to put in t. And now I need to solve this for x. So x, go ahead and distribute the 5. It's going to be negative 55t minus 105 divided by 13 plus, now I'm going to go ahead and get a common denominator here. So 4 times 13 is 52. So this is like 52t over 13 equals negative 8. All right, so combining these here, I'm going to get x minus 3t over 13 minus 105 over 13 equals, now getting a common denominator here, 8 times 13 is 104. So this is negative 104 over 13. All right, so x then is equal to negative 104 over 13 plus 105 over 13 plus 3t over 13, or 1 plus 3t over 13. So that means the solution, there are infinitely many solutions, all of the form 1 plus 3t over 13 for the x-coordinate, 11t plus 21 over 13 for the y-coordinate, and t for the z-coordinate.